mole. Let's go ahead and do the next one, number 3, which is a temperature problem, okay? So again, if you all know that you're given these problems, right, and you have to solve for certain things, why don't you go ahead and put the formula on your formula card so that you don't have to go through all the derivations of them? That would make life a little easier. Okay, that's what I would do. However, you don't have to do that. You can just go ahead and plug the numbers accordingly. Okay, so we're going to go back to our formula again. You are given the following information: the activation energy, the frequency factor, and the rate constant. They want you to find the temperature at which this reaction occurs. So again, for General Chem 2, a lot of times your professors are not going to take the time to show you the derivations of everything. But if you just practice doing all of this now, you don't have to wait on your professor. So this is what I mean about the derivations. Before we even plug in the numbers, I'm going to rearrange this equation. Okay, watch this. I'm going to subtract the natural log of A from both sides so that that cancels out. So it's like you're saying the natural log of K minus the natural log of A, that's equal to the negative activation energy divided by R and T. But now remember, in order for us to get the R and the T by themselves, you would have to still bring them over here to the other side. You would have to multiply, okay? You would have to multiply the R and the T so that you can get them together. And then that's where the math comes in, okay? Where you're going to multiply whatever value you get here when you subtract, you multiply it times the R and the T. Okay? And it's a lot of extra steps in doing that. And again, I'm just showing you all how these formulas are derived. And then that way you will understand why the answers come out to be what they are. Okay? So now in this case right here, because you're trying to find the temperature, okay, you would just plug everything else in. But what I'm going to do, guys, I'm actually going to start here, okay? I'm not going to finish that part off. I'm going to go ahead and just plug the numbers in here, okay? So that you could at least see this part right there, okay? Let's use this as our main formula right here, okay? All right, now, I'm going to go ahead and start plugging these numbers in, okay? In case you're like, okay, well, wait, what goes where? All right, this was your T. This is what you're looking for. That's that bottom number right there, okay? I'm going to go ahead and color code everything so you'll know. The activation energy number right here, that goes on top. Notice it's in kilojoules per mole. Go ahead and multiply that times 1,000 so that you're able to already have your number, because if you put in the wrong number now, your answers are going to be wrong later. So this is equal to 60,000 joules per mole. Now, the next thing that they've given you in your problem, your frequency factor, okay? Right here. That's this one right there. And then they also gave you your rate constant, okay? Which is right here. So I'm showing you where to put these numbers. I'm showing you where to put the numbers. And then your R. This is what we had from before. Okay? Your R. Right here. You're going to put your R on the bottom. Okay? That number right there, Goes right there. So what you're looking for is what's in purple. Why times it by 1,000? Trinity, very good question. Because 1 kilojoule equals 1,000 joules. Just like 1 kilo equals 1,000 grams, 1 liter equals 1,000 milliliters, 1 kilojoule equals 1,000 joules. Okay? So now we're going to go ahead and plug in the numbers that we know. The natural log of K, so the natural log of 2.0 times 10 to the negative second per second. And really, truly, y'all, you don't have to put the per seconds there because it's going to cancel out anyway. Natural log of 2.0 times 10 to the 12th minus the natural log of 1.0 times 10 to the 13th equals 60,000 joules per mole on top divided by 8.314 joules per mole dot Kelvin times the unit you are looking for. Remember, you are looking for your temperature. So that's going to be the unknown that you're looking for right there. Okay? That's what you're looking for. So now I'm going to scoot everything up so we can go ahead and now just go ahead and finish this off. Go ahead and do the math part right here, okay? What's 2.0 times 10 to the negative 12th, to the negative second, 2.0 times 10 to the minus second minus 1.0 times 10 to the 13th. Do that part and then get the natural log of that, okay? Then get the natural log of that. So 2.0 times 10 to the negative second, because you're going to have to take the natural log of both. So rather than doing the natural log twice, do this part first, okay? Do the 2.0 times 10 to the negative second minus 1 times 10 to the 13th. And I get 1 times 10 to the 13th. I'm going to get the natural log of that. And I get 29 right here, okay? 29.93. So all of this right here is equal to 29.9. Okay, we don't have to put the 3 on there. Okay? Equals 60,000 joules per mole divided by 8.314 joules per mole dot Kelvin times, and remember you're looking for what? Temperature. So times your T right there. Okay, definitely not Maria. What you have to do is take that negative sign off and then hit the natural log button. See, because if you do it like this, if I say, because remember earlier it was like 1.13 times 10 to the, let me go back. Let me see what it was before. 2.0 times 10 to the negative second minus 1 times 10 to the 13th. I got negative 1 times 10 to the 13th. If you put it in with natural log like that, you will get the error button. So you have to take the negative sign off of that number. So even though it was negative, you take the negative sign off to get the actual number, okay, to get the natural log of that number. Okay, we're almost finished with this problem, almost finished. What you need to do now, okay, you're going to multiply, okay? You're going to multiply these two numbers right here. So you're going to say 29.9 times 8.314 joules per. You see why you have to have pre-algebra or like basic algebra classes to know how I am isolating this. Okay? That's what I'm showing you right here. Okay? You leave that T over there. That's equal to 60,000. And you know what, too, guys? What I should have done, I should have just gone ahead and showed you all. I'm canceling out the joules per mole because we don't need that anymore. And that's just taking up space anyway. So I'm canceling that out, okay? Because the joules per mole, the unit canceled out, okay? And because the units canceled out, this is what you're going to end up with right here, okay? And remember, the T is still on the bottom because that's what you're looking for. So go ahead and multiply 29.9 times 8.314, and you get 240. We're going to round out to 249. 249 equals 60,000 over T. Now, all you guys got to do at this last point, swap these two out. Swap them out. Okay? And when you swap them out, like you're going to switch, they're going to switch places, not swap them out. They're going to switch places. So you're going to basically say T equals 60,000 divided by 249, and that gives you your answer in Kelvin. Okay? So 60,000 divided by 249, and I get 240. Kelvin. Yeah, you can say 241. Yes, 241. Mm-hmm. Yes, 241. If I were you guys in class, I would redo the problem again. The same way that your teacher did it, do it again and again and write the formula out. Just practice isolating each letter. You know what I'm saying? Just practice writing each letter out and solving for the unknown. Because then in that way, you're able to see your answers a lot clearly. Okay? You're able to see your answers a lot clearly. Okay. So here's what I recommend, y'all, okay? In chemistry, when you get to these sections here where it's a lot of steps, like what we did earlier, okay, I'm going to pause for a moment so y'all can digest all these problems that we just did, okay? Highlight what's given in your problem. Make sure that your activation energy is in joules by multiplying it times 1,000. Do all the math that you have up top first. Like do the bottom numbers first and then put it back in your calculator and divide. So that way you're able to get to the final steps. 45,000 divided by 2494.2 gives you e to the negative 18.04. And you remember what I said before, in case some of you all weren't here, if you leave the negative off, you're going to get a completely different answer. So you want to make sure that you incorporate that in your problem. Leaving it off will give you a completely different answer. Color code everything that's given so that you'll know what you're looking for. Practice writing these formulas out so that you'll know what to plug where. You'll know what to plug in where, okay? Practice writing the formula out, read the problem, and start to plug in the numbers of where they need to go. And let me tell you, sometimes you may end up catching your mistakes, but if you go back and write everything out, you'll know where the mistakes were once you do every part of the problem. And also, your teachers can see what you did. And then we give partial credit. But if you didn't do all this work here, you probably won't get extra credit. I mean, you won't get partial credit. And the purpose of the partial credit is by showing that you did attempt to set it up a certain way and that your numbers may have been off a little bit, but I can go back in and see why your numbers were off. Okay? Yeah, we're going to do number 4. We're going to do number 4. Solving for the frequency factor.